Hello friends, today we start the topic nuclear chemistry from Inorganic Chemistry paper. So this is first part of nuclear chemistry. This video is first part of nuclear chemistry. Okay, so in nuclear chemistry topic, what we see, what is mean by nuclear reaction, what is mean by energetics of nuclear reactions, types of nuclear reaction, from that artificial transmutation, artificial radioactivity, nuclear fusion, nuclear fission in that liquid drop model, then heavy water reactor, then use of uranium, thorium, plutonium, then application of radioisotopes as tracer. Okay, so in part first we see some point, we covered some point. For other points you can visit my Swapnali S. Jadhav channel and see other videos for remaining point. Okay, so let us start nuclear chemistry. So nuclear chemistry is important branch of science. It deals with study of nuclear particles, nuclear forces, and nuclear reaction. Okay, so friend, please tell me, what is the smallest unit of matter? What is the smallest unit of matter? So smallest unit of matter is atom. Do you know the structure of atom? So structure of atom what consists? At center there is presence of nucleus, and around the nucleus extra nuclear region present. So in nucleus proton and neutrons present, and in extra nuclear region electrons are revolve in different shells. Okay, so this is the structure of atom. So structure of atom what contains? Central positively charged nucleus and extra nuclear region where electrons are revolve in different shells. Okay, so atom consists of how many fundamental particles? So atom consists of how many fundamental particles? That is 3. Which are that? Proton, neutron and electron. So from that, proton and neutron are present in the nucleus. Proton and neutron present in the nucleus. It is called as the nucleons. Called as the nucleons. So in atom, number of proton always equal to number of electron. Therefore atom is electronically neutral. Okay, atom is always neutral. Why neutral? Because it contains number of proton is equal to number of electron. Okay, friends, can you tell me about the atomic number, mass number? Okay, so atomic number is represented by which letter? Atomic number is represented by letter capital Z. What is the definition of atomic number? the number of proton in the nucleus is nothing but the atomic number of the element. The number of proton. Number of proton. Or do you know, always in atom, number of proton and number of electrons are equal. Therefore, atomic number is nothing but the number of proton or number of electron. Okay. Then tell me, what is mean by mass number? Mass number. So mass number is represented by which letter? Capital A. So mass number is nothing but the total number of protons and neutrons in an atom. Total number of protons and neutrons in atom is known as mass number, or we can also say that total number of nucleons, because nucleons means proton plus neutron, is called the mass number, and it is represented by letter which? Capital A. Okay. So composition of any atom is represented by element having consider the symbol X with atomic number Z as subscript and mass number A as superscript. Okay. So how we can represent it? XZA. Okay. Where X is element, whatever, Z is atomic number and A is mass number. For example, carbon 6, 12. Okay. So 6 is the atomic number of carbon, 12 is the mass number of carbon. Okay. Understand? So do you know that proton is positively charged and it is represented as P11 or H11. Electron is negatively charged and it is represented as E-1, 0, and a neutron is chargeless and it is represented as N01. Protons are positively charged, electrons are negatively charged, and neutrons are chargeless. So this is basic point which are very important to understand the nuclear chemistry topic points. So generally in chemical reaction electrons are involved, but in nuclear reaction nucleus or nuclei of an atoms are involved. So what is mean by nuclear reaction? Nuclear reaction. What is mean by nuclear reaction? The reaction in which nucleus of an atom undergoes transmutation is called nuclear reaction. The reaction in which nucleus of an atom undergoes transmutation. Transmutation is known as nuclear reaction. Okay. So now one another question is arised. What is mean by transmutation? What is mean by transmutation? So definition of transmutation is the process in which atom of one element is converted into atom of another element is known as transmutation. The process in which atom of one element is converted into atom of another element is known as transmutation. Okay, understand? So nuclear reaction is the reaction in which nucleus of an atom undergoes transmutation is known as the nuclear reaction. Okay, for understanding we see one example. For example, beryllium of mass number 9 bombarded by alpha particle, then there is formation of carbon 612 with emission of neutron. Here beryllium of mass number 9 is bombarded. When bombarded by alpha particle, then it is converted into carbon having mass number 12 with emission of neutron. This is known as nuclear reaction. This is known as nuclear reaction or nuclear equation. Okay, here subscript, these are the subscript, indicates what? Atomic number या mass number? Atomic number. And superscript indicates the mass number. So on both sides of that nuclear equation, sum of atomic number and mass number must be same. Sum of atomic number and mass number must be same. This nuclear reaction can be represented in the abbreviated notation by scientist Bethe. So how he represented? So this reaction is represented as beryllium 9 in simple bracket alpha comma neutron simple bracket complete carbon 12. So according to Bethe, this reaction is represented like this. Okay, here beryllium 49 is known as target nucleus. Okay, so what is mean by target nucleus? The element bombarded by some projectile is called target. Element bombarded by some projectile is known as the target. Okay, so alpha is known as projectile. So what is mean by projectile? The particles used for the bombardment in nuclear reactions. Particles used for bombardment in nuclear reaction is known as projectile. In simple bracket, second symbol is of neutron. It is known as the emission. And last is of called recoil nucleus or daughter element. Recoil nucleus or daughter element. So what is mean by recoil nucleus or daughter element? The product obtained in nuclear reaction. The product obtained in nuclear reaction is known as the recoil nucleus. So what is mean by nuclear reaction? Nucleus of an atom undergoes transmutation is known as nuclear reaction. Here we see one example. In that example, when beryllium of mass number 9 is bombarded by alpha particle, then what happen? It is converted into carbon having mass number 12 with emission of neutron. So here subscript indicates atomic number, superscript indicates mass number. This is known as nuclear equation. In nuclear equation, sum of atomic number and mass number must be same on both sides. Must be same on both sides. Okay. Here this nuclear reaction is represented in the abbreviated notation by scientist which Bethe. So according to Bethe, first notation is of target in simple bracket. First notation is of projectile, second symbol is of emission, and last one is recoil nucleus or daughter element. So what is mean by target? The element bombarded by some projectile is known as target. What is mean by projectile? Particles used for bombardment in nuclear reaction is known as projectile. What is mean by recoil nucleus or daughter element? The product obtained in nuclear reaction is known as the recoil nucleus or daughter element. Okay. So I hope you understand about what is mean by nuclear reaction, example, and their notation, how it is noted. Okay. Then the some particles used as projectile or get as emission, you must know about their symbol, their mass number, atomic number. Okay. So first one, alpha particle. Alpha particle is nothing but the helium nuclei. So He24. It is represented as He24. Neutron. Neutron is represented by N01. Then next one is proton. Proton is nothing but the nucleus of hydrogen. So it is represented by P11 or H11. Okay. Then next one is deuteron. Deuteron is nothing but the isotope of hydrogen. It is represented by symbol small d having atomic number 1 and mass number 2. It is known as deuteron. Then next one is gamma rays. This is symbol for gamma, 0, 0. So these are particles used as projectile or we get as emission or ejectile. Okay. So for better understanding, we see some another example. Okay. From that, please you can tell me how this reaction written according to Bethe and identify projectile, target, recoil nucleus, emission. Okay. So here aluminium 1327 when bombarded by deuteron. Deuteron D, it is represented as D12 or H12. It is isotope of hydrogen. Then there is emission of alpha particle. So alpha particle He24. So please tell me which one is the recoil nucleus, or which element obtained as daughter element. So you know that sum of atomic number and mass number on both side of equation are same. Okay, so here atomic number are 13 plus 1 is equal to 14. Here atomic number already 2, therefore 14 minus 2 is equal to 12. So the element having atomic number 12 is which element? Magnesium. So magnesium 12. Mass number 27 plus 2 is equal to 29 minus 4 is equal to how many? 25. So mass number is 25, means the product obtained is which one? Magnesium 1225. So then we write that nuclear reaction in the form of methane nuclear equation. How it can write? Aluminium 27 simple bracket projectile. Which one is projectile? Deuterium, comma emission. Which one is emission? Alpha particle. Simple bracket complete. And which one is the recoil nucleus or daughter element? Magnesium having mass number 25. Okay, so this is the according to Bethe notation. So tell me the target. Which one is target? This one is target, aluminium 27. Which one is projectile? Deuterium, projectile. Which one is emission or ejectile? That is alpha particle. And which one is the recoil nucleus or daughter element? Magnesium 25 is the recoil nucleus, or it is also known as the daughter element. Okay, then we see next point, energetics of nuclear reactions. Energetics of nuclear reactions. So nuclear reactions are associated with loss of energy or gain of energy. Nuclear reactions are associated with loss of energy or gain of energy. So when energy is lost or energy is released during nuclear reaction, then these nuclear reactions are called exoergic or exothermic reactions. Exoergic or exothermic. And when energy is gained or absorbed during nuclear reaction, then this nuclear reaction are called Endoergic or endothermic. Endoergic or endothermic. Okay, we see example of exoergic. For example, when deuterium is bombarded by another deuterium, then there is formation of tritium plus emission of one proton, and here energy is lost is 4.0 million electron volt. Okay, and example of Endoergic is when nitrogen having mass number 14 is bombarded by alpha particle, then there is formation of oxygen having mass number 17 with emission of proton. Here energy is absorbed is minus 1.16 million electron volt. 1.16 million electron volt. Okay, so the amount of change in energy is enormous and calculated with the help of famous energy equation. Which one? Einstein equation. So Einstein equation is E is equal to mc square, E is equal to mc square, where E is the total energy released, total energy released. M is the mass defect, and C is the velocity of light, So mass lost is converted into energy. The nuclear energy can be converted into other forms of energy such as heat, electricity, etc. So up to that we completed what is mean by nuclear chemistry, what is mean by nuclear reaction, what is mean by transmutation, then how is nuclear reaction is represented. From that we see what is mean by target, what is mean by projectile, what is mean by recoil nucleus emission. Okay, and then we see next point, which one? Energetics of nuclear reaction. So nuclear reactions are associated with loss of energy or gain of energy. So when energy is lost or released, it is known as exoergic or exothermic, and when energy is gained or absorbed, then it is known as the endoergic or endothermic. So example of exoergic is H12 plus H12, it is converted into H13 plus H11 with 4.0 million electron volt energy. An example of endoergic is when nitrogen 714 plus He24, it is converted into oxygen 817 plus H11, and energy is minus 1.16 million electron volt. The amount of change in energy is enormous, which is calculated by famous equation, that is Einstein equation. E is equal to mc square, where E is total energy released, M is mass defect, and C is velocity of light. Okay, I hope you understand the energetics of nuclear reaction. Okay, thank you very much for seeing my video. So for another videos, you subscribe my Swapnali S. Jadhav channel. Okay, then like and subscribe my channel, like the videos, share to your friends also. Okay, thank you very much.